the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on electromagnetic induction. In our previous lesson, we learned about induction and the energy volume of magnetic fields. We studied the formula for self-inductance and magnetic field density. Today, we will be discussing electromagnetic field induction as it applies to alternating currents. We will also learn the function of alternating current generators and transformers. If you are ready, let us begin. An electric generator converts mechanical energy to electrical energy. A coil in a magnetic field experiences a torque that will make it rotate. And as it rotates, an EMF is induced. There are two types of currents. Direct current has a constant value and is a type of current obtained from cells. Alternating current constantly vary and are a type of current that is transmitted from power stations to provide us with electricity. This video shows the components of an alternating current generator. First, we introduce our cylindrical magnetic poles, from which a radial magnetic field will be generated. An armature composed of a soft iron core and a large amount of coiled and insulated copper wire is introduced as a means to collect energy from the two poles. This is achieved by attaching two metal slip rings to the base of the armature, which will spin with the armature as the magnetic field causes it to rotate. The rings are insulated from each other and are in contact with two carbon brushes. These brushes are connected to an external circuit, which, in this case, are transmitting the current to the galvanometer. The current itself is generated by the induced electromagnetic field, which is caused by the constant rotation of the armature. Students, let us review this data with a quick activity. What are the key components of an alternating current generator. Why are they important?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Let us review the components of an AC generator and see if our answers are the same. All alternating current generators require two opposing magnetic poles to generate a magnetic field. We also need an armature or coil inside this magnetic field so that we may induce an electromagnetic field. We need 2 insulated metal rings to collect the current. Lastly, we need an external circuit to transmit the electrical energy to the object that needs power. If you properly defined the components and their importance, great work. Now that we know how to generate an alternating current, we also need to understand how to control the flow of electricity so that it is not too much or too little for our needs. This is achieved through the use of a transformer, a tool used to change or regulate the voltage and current generated by an electromagnetic field. The main component of the transformer is a rectangular insulated soft iron core. The core is laminated to avoid the heating effects of the eddy current. One side of the core is connected to the alternating current provided by a generator through a series of copper wires, creating a coil. The primary coil of a transformer is the coil that receives the charge from the AC generator. On the other side of the transformer, another set of copper wires is coiled, carrying out the newly regulated current to its destination. This is called the secondary coil of a transformer. How much wire we coil around either side is determined by whether we are making a step-up transformer or a step-down transformer. A step-up transformer has fewer, thicker loops in the primary coil, while the secondary coil has significantly more loops in the coil, made up of thinner wire. This allows it to convert a low voltage with high current to a high voltage with low current. In a step-down transformer, the primary coil is made up of thin wire with many loops, while the secondary coil is composed of thick wire with fewer loops. This allows it to convert a high voltage with low current to a low voltage with high current. Transformers are commonly used to carry an alternating current over long distances. Without them, we could not power an entire city. However, when electricity flows through cables, power is lost due to the resistance of the cables. Thus, we tend to transmit electricity at very high voltage, since this resistance reduces the current. However, the electricity that reaches our homes and businesses arrives at a much lower voltage. This is because there are also transformers at the other end of the current, to reduce the voltage to usable levels. Students, let us test our understanding of transformers with an activity. What is the purpose of a step-up transformer? What is the purpose of a step-down transformer?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. To answer the question, the step-up transformer is used to convert a low voltage with high current to a high voltage with low current. A step-down transformer is used to convert a high voltage with low current to a low voltage with high current. Students, today we have learned how an electromagnetic field is used to generate electrical energy in an alternating current generator. We also examined the components and purposes of both an AC generator and a transformer, so that we may better understand the transmission of electricity. Until next time, thank you, teacher. Thank you, students.